All right. Sure, we'll do that. All right. Okay, hello, everybody. How's everybody today? I hope everybody is fantastic today. Good evening to you, Hisa. How are you? Good evening to you. I hope you're well. Figure out a couple things here. That's okay. One less, right? One less. All right. Good. Yeah, I'm doing fantastic. Today is another good day. We're doing pretty well. 100%. Been pretty chill today, so I'm pretty happy. I'm pretty happy. I'm pretty chill. It's been pretty alright. How about, how's, plans for the weekend here? Hopefully. Good to hear. Hopefully you have plans for the weekend. Nice and hopefully relaxing a bit. We got some stuff to do today, but nothing too crazy. I promise you that. Easy time, easy life today, ladies and gentlemen. Easy time, easy life. I think this will be nice and simple. Nice and simple. Alright, we'll wait for a couple more minutes here, and then we'll go ahead and get started. And then we'll do our stuff. And then there you go, bada bing, bada boom. We will get things rolling. It's right. Oh, guess can't worry about that right now. You think I'm top of my game with all the assignments? We should have time. Very good, very good. Hello, Big Chimp, and how we doing, my friend? How we doing? You're on top of all your game with all the assignments. Again, we get all that stuff done, get it going, and the semester comes, you'll be able to focus on just that final exam. Hopefully, good. Doing good, just chilling. Excellent, excellent. Again, just making a nice, relaxing day, everybody. No problem. All right. We will start here in just another minute here, ladies and gentlemen. And then we'll go ahead and get going. Okay, let me, actually, I'm gonna go grab some water here for just a moment. Hang on. Alright, some tea would probably do me some good. I've got tea instead. Alright. Okay, let's do some intros here. Let's go ahead and get started here. And, yeah, let's do it. Alright, let's go. Okay, let's get started today. Welcome back to Thursday. End of the week time today. So today, we are going to be doing the second section here of Chapter 10. Last time on Tuesday, we did a nice introduction here for hypothesis testing. So we talked about the null and alternate hypotheses. We talked about how to go ahead and identify those things in a given problem here. Again, let's go to the big board here and remind ourselves what exactly that we looked at here last time. So let's take a good look. So here, again, we did talk about, again, the null, which was H0, the alternate, which was H1. We also talked about the left, right, and two-tailed type of tests. Okay, so again, left tail being less than, right tail being bigger than, two-tail being not equal to. And we also talked about conclusions. We talked about, again, the significance level. Talked about all that stuff here last time. We were able to identify how to write out a couple of steps here as part of the process. Now today, we're going to be using that same idea we talked about here on Tuesday, and of course, we're going to now apply it to actual real hypothesis testing kind of problems. Alright. I hated math in school, let alone on Twitch. Well, I'm sorry, my friend. So did I. Although, to be fair, Donnie, I didn't have Twitch back in the day, so... there was barely an internet back in the day. And yet, somehow, some way, all these years later, here I am. True story, Donnie. I failed math a few times, so I don't mind if you don't like it. That's perfectly okay. But if you know how it applies to what you could be doing in the future, I don't think that's so bad either. It'd be like that. Yeah, math and me, we're not friends. We're not friends for a while. It's true. I was never like the super prodigy, alright? I don't want to be the super prodigy guy. Like, oh my god, you're a math teacher, and you're like, oh, you're super smart at math all the time. Be like, bro, it ain't like that. Far from it, man. Okay, so we're going to be doing actual real-life hypothesis testing problems here, and we're going to be actually using them and be able to draw conclusions from these hypothesis testing problems here. So let's go ahead and take a look at question 8 from the last handout. Alright, so we're going to start at question 8, and this is going to be reflecting on section 10.2. Okay, so what we're going to be looking at here in section 10.2 is talking about a population proportion. So again, it's like, again, we're asking people questions, you know, do you like brand A? You could say yes or no to the question. You say, yeah, I like brand A, whatever. Alright, and again, we can hypothesize in comparison to a precedent and see if our conclusions hold true or not. Just depends. Alright, so what assumptions must we make to do a hypothesis test for a population proportion? A letter A, a simple random sample or a data from a randomized experiment. So again, every person that you select or everything that you select must have an equally likely chance of being selected. Okay, so it has to be a simple random sample or again, purely randomized. Letter B, we have to have a large enough sample size, so we have to have NP times 1 minus P has to be bigger than or equal to 10. So if we have a sample size of a pretty small one, that may not be sufficient enough for us to go ahead and actually figure that out. So, you know, a good enough sample size will do. We just have to make sure that we specify that condition. And letter C, the sample values must be independent of each other. That's true. Again, one person can't influence another person. All right. So again, otherwise that would destroy the entire credibility of your actual hypothesis. All right. Okay, so those are the assumptions that we must make here. Now, let's talk about the steps, all right? And we'll look at an example here. So, talk about the first 3 steps here. Pretty much the same as what we did last time. And then set ourselves up for the last 3 steps. All right, let's look at step 1. Step 1 here, we have to determine the null and alternate hypotheses. Now, to let you know what's our null, what's our base case here. Our null hypothesis here is going to involve the population proportion. So that's what I've written here. P is equal to the population proportion. So whatever it gives you in the problem, whatever number it gives you, population proportion, that's going to be the number that you're going to plug in there just like so. What's your alternate hypothesis? Again, you could have less than, bigger than, or not equal to whatever population proportion is given to you in the problem. Step 2, determine the type of test, just like we did last time, left, right, or two-tail. And of course, state the level of significance. Again, we don't need to find that. It'll be given to you in the problem here, but we're going to need to state that here in a separate step as well for purposes that will be apparent once we get down to the end of the problem. All right. So, having said that, let's go ahead and take a look at an example. All right, let's look at an example, and we'll work on this together here. You guys help guide me through these first few steps, and then we'll look at the last 3 steps here, and we'll work on those together. Okay, so let's take a good look here at number 17. That's slightly bigger. Let's make this a bit bigger too. There we go. Alright, let's look at 17 here. The drug Lipitor is meant to reduce cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the 0.01 level of significance? Alright, so let's take a good look here at this one. Let's go ahead and go through each step here carefully. Alright. So we'll start with our null hypothesis here. Alright. Now remember, our null hypothesis here is going to be, let's again go over that. Again, that's our population proportion here. So let's do that here. What is our null hypothesis here, according to the problem? What is H0? What is our null hypothesis? What do you guys think? What's going to be our null hypothesis? What number are we going to have here for our population proportion? Put your guesses in the chat here. What do you think? What's our population proportion going to be equal to according to our problem here for number 17? .019. That's correct. Very good. That is absolutely right, Jake. Good. So the claim here, let's go over that. 0.019, which reflects, again, 1.9%. So if we take a look here, it says, all right, it's known in the population that 1.9% of patients take competing drugs complain of flu-like symptoms. So that's going to be our metric that we're going to compare against. All right, so 0.019 is the correct answer here for our null hypothesis. All right, let's do our alternate hypothesis. Now again, here's how it works for the alternate hypothesis. It's fairly simple. We're just going to write the same letter and write the same number. Okay, remember, same number here has to go twice. Same letter too. The only thing that we care about is what goes in the middle. It's either less than, bigger than, or not equal to. So which one do we have here for our alternative hypothesis? We have less than, we have bigger than, or not equal to. Which one do we have here in this case? Do we have P is less than 0.019. P is bigger than 0.019. P is not equal to 0.019. All right. So let's take a look here. Is it more than? I would think so. I think that's correct here. We're going to have more than. Again, it says, is there evidence to conclude that more than 1.9% experience these symptoms? Okay, so that's fair. You have more than here. All right, good. Okay, so based off of that, what type of test do we have? What type of test do we have? Do we have a left tail test, a right tail test, or a two-tail test? Do we have a left tail, right tail, or two-tail test? Okay, that's right. We definitely have a right tail test. All right, so far so good. All right. All right. Okay, now we will come back to this right tail test in a second. But let's write down the next step here. I have one more step. So the last step here, step 3 that we're going to talk about right now, is we have to state the level of significance. Now that's just given to you here in the problem at the very end. It's given to you here as alpha is equal to 0.01. So again, nothing that you have to find. It's just there. All right. So these that you can see here are the first 3 steps as part of the process to do hypothesis testing. All right. Now before we move on here, are there any questions so far? Any questions so far? All right, no. Okay, cool. Okay, now, let's talk about the next part here then. If there are no questions, we'll move forward. All right, so let's talk about the last 3 steps, because these last 3 steps here are going to be very important as well. Going to help us figure out a few things. Let's look at step 4, step 5, and then we'll talk about step 6 here as well. All right, step 4. Compute the test statistics. So what we're going to be doing as part of this process here is we're going to be finding out what a test statistic is going to be. Now, each time we do this in both of these sections that we'll do here in Chapter 10, there'll be a different formula about how to find these test stats. So the formula that I have up here is essentially the test stat, the formula here for the test stat that we're going to find. So as you see here, the notation for each of them, X representing the number of yeses we get, for example, N is the sample size, P the population proportion, and again, Z0 is just the fancy guy for test stat. Alright, so Z0 here being that fancy notation, again, test stat would be equal to X over N. Now, in the book, I will point this out here, in the book, they don't label this as X over N. They actually make this they actually put this as like P hat, and honestly speaking, that's actually a bit harder to kind of get along with. So instead, I make it a bit easier, and I want to be like, okay, you put X and N there in their respective places, so it'll just be easier to work with at the end of the day. All right. In any case, what we need to do here specifically is let's go ahead and mark down some important pieces of data that we do need, because even though we need to find out what this test stat is, we do need to mark down at least the parts of the test stat in this particular case. So let's do that right now. Okay. Let's identify first X and N. We need to find both of those. We need to find the number of yeses and the sample size. We already have P here. P is the 0.019. So let's identify X and N here for this step. What is X going to be here? What is X equal to in this particular problem for 17? What is x equal to here? How many people said yes to these flu-like symptoms, for example? 19. Okay, very good. So 19 is correct. So the 19 people, as we have that there, very good. Nice job, everyone. All right. And how many people did we survey overall? So what's our sample size? What's n going to be? Let me get here for n. 863. That is correct. Good. We have 863 people that we went ahead and surveyed. All right, so Chip and Jake, Hisa, and Shioma, all correct here. All right. Now, we could plug this into the formula here. All right, we'll come back. We won't need the problem here for the rest of this. So we can plug this stuff into the formula. Now, if you were to actually do the test stat here, here's what it would look like. You know, if I were to plug it in using the formula that you see off here to the left. All right, so I would literally have 19 over 863 minus 0.019, all that divided by the square root of 0.019 times 1 minus 0.019 divided by 863 here. Now, if I took a look at this here, if I took a look at this test stat here, there is one problem with this test stat. I think it's pretty clear what the problem with this test stat is. It's incredibly ugly. All right? It is very ugly to plug into a calculator. Even in a calculator, this looks pretty awful. All right? So, what we are going to do here is we are not going to enter this into the calculator, okay? I do not recommend for you to plug this into the calculator. Please do not. Okay, it will turn out to be not such a great thing, okay? I will tell you that right now. All right, so instead, what I would like you to do here is we're going to move to the next step here and be able to find this test stat here at the same time as finding finding a very important critical p-value here. So again, we're going to do this kind of at once here. So I just have the numbers put in here for the sake of kind of illustrating the example here. But again, you should not be entering this into the calculator. We're going to use something else in the calculator in order to find out what this test stat is. So in step 5 here, let's take a look at step 5. Step 5 says use the calculator, specifically the 1-prop-z test, to determine the p-value. All right, so we're going to take our information that we have here, and we're going to find a particular p-value as part of this process. All right. Now, how do we go ahead and do that? Well, let's go ahead and take out our calculator here. All right, and let's see what we get here for our p-value. Okay, so first and foremost, everyone, once you have your calculator out in front of you, please type "got it" in the chat, and we will get started. Okay. Let's make sure everybody's on the same page here. Chioma, are you okay? If you have your calculator there. All right. Maybe Chioma stepped away for a second. That's okay. All right. Okay, so, all right, so let's go ahead and take a look at how we can do this on the calculator here. All right, so let's go through the button presses here in this particular instance. All right, so let's go ahead and hit the stat key here once again. So we'll go ahead and hit the stat key. And we're going to scroll over to tests, okay? So we're going to scroll over to tests. Now, we want to scroll down to a particular item here. We're going to use number 5, which says one prop Z test, okay? So number 5, one prop Z test. So let me put this in the chat here. All right. Should really mark that on the... All right, go ahead and hit enter. All right, so this is what you should see here on your screen. Doesn't matter if you have a new school or old school calculator. It'll look pretty much similar to this. Okay, let's go over what numbers we need to enter in here, because that is definitely an important thing to know. All right, so going through this here, let's look at the very first thing we see at the top of the screen. We see this P0. This P0 is, in effect, your population proportion here. All right, so this is what we first defined in our null hypothesis. So we're going to put 0.019 here for P in the very first part. The next part here is why we will go ahead and write down what X and N are. So because X here, as we identified, is 19, and N here is identified as 863. All right. Now, the last part here in your calculator is very important, okay? And this is the reason why I have a separate step for the type of test. So there is a reason, there's kind of a method to the madness here about why we choose the type of test. You need to tell the calculator what type of test you have. In this case, we have a right tail test. So we have a two tail. Again, it's written this way here. Again, you have not equals P0, less than P0, bigger than P0. So essentially, this is the first one here is a two tail test. Then you have a left tail test, and then you have a right tail test. All right, so it goes two tail, left tail, right tail on the calculator. So the one we want to choose, of course, in this case, is the right tail test. So we're going to highlight this last guy here and hit enter. Okay. Again, two tail, left tail, right tail in that order. And then we want to go down to calculate here. And then we're going to see what we get. Okay. Now, before we move forward here, let's make sure everybody got the same numbers here. Type "got it" in the chat if you have the same exact numbers as you see here on the screen. Okay, Chioma got it. And Gaily got it. Okay, good. See if Issa and Jake got it as well. We got different numbers, okay. All right, Jake, make sure you put it in correctly. Here are the numbers that you need to have. Take a look at my numbers. 0.019, 19, 863, and make sure you have it, the last one set to a right tail test. That will be highlighting this last part here, Jake. And then hitting enter on that. So this is what it should look like here before you hit calculate. Okay, cool. Okay, now let's take a good look here at the numbers that all of you got. If you got the same exact numbers here on the calculator, which you've all confirmed now that that happens to be the case, let's take a look at the recap here from what we see from the calculator. So, first and foremost here is this very first number you see here, which says Z. This Z equals guy is going to be our test stat. So, like I said, you don't need to enter all that stuff in the calculator. It figures it out for us here. Our test stat here is 0.6490. So, let's go ahead and put that in. Okay, and then we also have the p-value here, which is right below it, this p equals part here. So this p equals part here is also important. We want to put that down here for step 5. So we have 0.2582 as our p-value here. All right, great. Okay, so we have those numbers there. Now, of course, you have the, again, you have a p hat, which is, again, 19 out of 863, and they give you the sample size. Okay. The only two numbers we care about, though, are these first two numbers we see here. All right. In any case, let's go ahead and move forward. And now we're done with the calculator part here. We're now ready to go ahead and start making a conclusion. So let's move to the next step here and see what this is all about. So, step 6, the last step, making a conclusion. As we talked about last time, we only have 2 possible final answers, so we have to determine which one of those 2 final answers that we're going to fall underneath. So how does it work? Well, it's very simple. It says, if we make a conclusion, it says, if the p-value is less than the level of significance, that's the thing in step 3, that's why, again, I write that as a separate step. If the p-value is less than the level of significance, we will reject the null hypothesis and accept the alternate. Otherwise, we accept the null and reject the alternate. Okay? So that is, again, you're going to fall underneath one of those 2 categories. So the easiest way to kind of put this down, and so that way it's easier to remember, is just ask a question to yourself. So the question is fairly simple. Be like, okay, is our p-value here 0.2582 less than our level of significance here, which is given to us as 0.01? All right, so let's ask that question here. Is 0.2582 less than 0.01? Yes or no? Well, this shouldn't be too hard, I hope. Question mark? No. Okay, definitely not, right? That definitely makes no sense, right? So the answer is no. So because the answer is no, which one of these 2 answers would be the correct conclusion? Again, we only get 1 of 2 answers here. So again, which one of these 2 answers that you see on the left here for step 6, which one of these would be the correct conclusion if the answer is no? What's our conclusion here? You got 1 of 2 choices. So accept the whole thing, guys, the whole thing. Because it's on the... I want to say the whole thing here because on the homework it's also going to say the whole thing. So, just got to be careful. So accept the null and... and reject the alternate hypothesis. Yes, that's correct. We're going to accept the null hypothesis, accept the null, and reject the alternate. I know that seems a little silly to say, but at the same time, just make sure that you're covered there for the homework problems. All right, good stuff. All right, great. Okay, and that is the end of that example. Any questions? Any questions so far about that? Now we have the 6 steps there. Should be hopefully a bit easier to do the next example. So, all right. Hopefully not too bad. Okay, let's focus on the next one then. Let's do that next one. Bring out the book back. All right. Okay. Which one do I want to do? Sure. Let's do that one. Let's do 21. Let's do 21. 21 says, let's look at 21. 21 says, in 1994, 52% of parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 of 800 parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use the 0.05 level of significance. Okay, let's go through the problem here. Let's go through each step, and we'll just put these 6 steps together and come up with the conclusion here. All right, so let's do it. All right, step 1. Let's do the null and alternate hypothesis here. Let's do it. So, what is the null hypothesis? What's our population proportion here in this case? What's our null hypothesis? What is H0? 0.52. All right. So far, so bueno. That is correct. Very good. All right. Now we got that set up. Very good. What is the alternate hypothesis? What is the alternate hypothesis? What's this claim that they're trying to make here in this problem? What's going to be our claim here? So we have a P, we have a 0.52. I just need something in the middle there. Remember, you only have 3 choices here. So, not equal to 0.52. Okay. That is correct, Jake. Very good. Again, the reason why it's not not equal to 0.52 is what we did here last time. It says, do parents feel differently today than they did in 1994? So the question is it different? Okay, it doesn't say it's less than. It doesn't say it's bigger than. It just said it's different, all right? So different means it's just not equal to 52%. Okay. All right, good. Not too shabby crabby. All right, what type of test do we have? What type of test do we have here? Let's look at step 2. What type of test do we have? Do we have a left tail, right tail, or two-tail test? Okay, left, right, or two-tail test? A two-tail test. All right, very good. So we definitely have a two-tail test. We're definitely coming back to that here once we get to that point. Let's look at step 3. Again, just stating our level of significance, which at the end was given as 0.05. So nothing too much going on there, but again, used for that comparison at the end of the problem. Alrighty. Let's write down our information here for step 4, because we're going to need it. Alright, so we definitely need step 4 here. We definitely need an X and an N. So, let's go over that here carefully. What is X and what is N? What is X and what is N? What is X and what is N? X is 256, okay. Okay, no, I got you, Jake. Alright, very good. So 256 people said yes to the question out of the 800 that were surveyed. Alright, seems fair. Alright. Now, remember, we do have a test stat to go with it. So, in case if you did want to check it, we could follow our formula here for our test stat. Let's look at our formula here for just a moment. Again, here's our formula. So again, if you want to write this down, and this is completely optional. I'm just showing this for the sake of the example. But if you want to say, hey, I want to check to see if I got it right on my calculator, hey, then you can do it if you want to. It's not super a big deal, but it is what it is. So here's what it would look like, at least from a manual perspective. All right, so and then divided by 800. All right. Anyway, let's look at what this test stat's going to be. And we'll go to step 5 here, which is finding this p-value here. All right. Okay, there we go. All right, let's get on our calculator here. Let's go ahead and start plugging in some numbers. All right, so let's hit the stat key here. All right, let's go over to tests. We'll go down to number 5, which says 1prop_z test. Hit enter. Okay, let's put in our numbers here. First of all, we'll put in our population proportion here, which was given to us as 0.52. X here is 256. Our N here is 800. And again, this time we want to pick a two-tail test. So let's pick the first option there underneath, and then let's hit enter on that. So this is what it should look like here on your calculator so far. Okay, and we'll go ahead and hit calculate. Alrighty. So let's take a gander here. So before we take a gander here, I would like you to type "got it" in the chat if you see these exact numbers on your calculator. Type "got it" in the chat if you see these exact numbers on the calculator. This is what you're supposed to get here, so don't be surprised. Good, good. Okay, excellent. Galley's got it? Okay, perfect. Perfect. All right, good. Everybody's pretty much got it here. All right, so I want to go over these answers here very carefully. So let's take a look at both of them. All right, first and foremost here, let's take a look at our test stat. Again, that's the first number we see here. So that's, again, a negative... I did want a different color here. Let's pick brown. All right. So let's pick, we get a negative 11.3228. Is going to be our test stat. Now, what can happen from time to time is that you get a very unusual looking p-value here. Now, this p-value, do not let it fool you, okay? So I do want to stress on this particular p-value here. This p-value here is 1.0396. All right, so if we took it out to 4 decimal places here. However, this is not just 1.0396. Remember, we have this e to the minus 29 here. All right, so what exactly does this mean? Well, this is scientific notation here. Much like when we did normal CDF and we did like 1e to the 99, that's essentially 1 with 99 zeros after it. Okay, that's basically what it means here to the calculator. 1 with 99 zeros after it. In this case, we have 1.0396 e to the minus 29 is the same thing as 1.0396 times 10 to the negative 29th power. that means that it's basically going to be 0 with 28 zeros, and then 10396. So, yeah, it's a really, really tiny number. It would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There. That would be what that number actually is. Okay. Yeah, it's a pretty small number here. So your answer is not 1.0396. All right, it is actually that number right there. Now, obviously, you're not gonna write 28 zeros. That's absolute bananas. All right, but you get the general idea. If you do see something like this, you move it over 29 places to the left. Okay, that's essentially what this is telling you here. Okay, so you move 29 decimal places to the left. It's kind of crazy, but it is what it is. Now, if you were to, of course, round this appropriately, then rounding this in the problem here would be effectively 0. Okay, that's because it's so small, it doesn't really register anything between 4 decimal places. But that's essentially what it is. So, if we go to step 6 here, let's ask this question here. All right. Is 1.0396 times 10 to the negative 29th. Remember, we need to make our comparison here now. So we're going to go to this last step. Is this less than, what's our guy here? All right. Is it less than 0.05? Yes or no, is this number here less than 0.05? Okay. Definitely yes. Okay? Absolutely 100% yes, right? It's super, super tiny. It's practically 0. All right? Pretty much. All right? It kind of reflects the Powerball odds, okay? But even worse than that. All right? Late stream, my hottie, it's like 450 over here. I ain't gonna lie. Okay, so what conclusion can we make? 4:50 in the afternoon. What conclusion can we make here in this case? What conclusion can we make then? Which one are we going to choose? Are we going to accept the null and reject the alternate, or reject the null and accept the alternate? That had so he says. Reject the null and accept the alternate hypotheses. Alright, good. Reject the null and accept the alternate. Excellent. I trust. I trust. Are you just saying? Okay, fine. You know what, Hadi? You know what? Alright. Alright. 100% this class. Me. Alright? All the time. So we're Alright, so we reject the null hypothesis and accept the alternate. Alright, very good, very good. Okay. All right. Any questions? Any questions from you guys? Ask away if you have questions. No? Okay. Would you guys like to try one more example? Or are you guys good? Just ask that before we move forward. One more example, or are you good? You guys think you have a good handle on it? Just depends. What would you guys like to do? It's up to you guys. We can end off here with this section now, or if you guys want to do whatever, it's up to you. So good if everybody else is good. All right. There's not much to it outside of those 6 steps, but I always ask anyway. Let's put a poll then. Wait, what did I do? Wait a second. Hang on. What happened here? Okay. Yeah, there we go. Let's put a poll here. I always like to see what's going on here. Just go with the majority here, and then we'll... I'm not voting here, obviously. I'm not voting, dang it! Alright. Not allowed to vote. Not allowed to vote. Sage. Alright. Okay, so looks like we are good. Alright, that's perfectly fine. I don't have a problem with that at all. Alright, let's view these results here. Okay, very good. Okay, so then we are just going to call it here for today. If you guys are good. Okay. Yeah, absolutely, Anna. 100% you can. Here is, let me put this, full screen here. Here you go. Actually, let me make this a bit smaller. I can fit it all in one page here. So this is number 8 and 9. This is the first part of the notes, because we finished up the first 7 questions here last time. And, let me know if you want to see the other half of the notes as well, if you don't have them already. Alright. Okay, ladies and gentlemen. While Anna is doing that, I want to thank everybody for coming on out here to the stream once again. It is a pleasure as always. Alright, it is a pleasure as always to have fun with you guys. Alright, put this, there we go. Actually, see if that gets in the way. It does, okay. Kinda sad. Let me try it this way, Anna. Give me a sec. Here we go. Put it on a no-face cam for this. This'll be easier. This I can promise you. Okay. Alright, cool. Alright. Okay, well, again, I want to thank everybody for coming on out here to the stream. All of you are fantastic today. And we are going to wrap up Chapter 10 here for next time in Section 10.3. Okay, so Section 10.3 will be the last part here of Chapter 10. And we're well on our way to finishing up here. Then Chapter 10 will be done after 10.3. We'll move to Chapter 4. And as a reminder here, if I didn't tell you last time, again, this weekend I'm going to be looking over your tests and homework and whatnot, and I'll be updating the gradebook on D2L. So that is one of my goals here for the weekend, is to finish that up so you can get up-to-date grades for you. All right? If you guys have questions or anything like that, you guys know exactly where to find me. I'm here on Discord. Again, you feel free to email me. I'm not going anywhere. Literally, I'm in my chair. So we will see you all, everybody. I hope everybody has an absolutely fantastic weekend, and we will see you all back here on Tuesday. All right? All right. Have a wonderful evening, everybody. Have a wonderful rest of your day. Have a wonderful weekend, everybody. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right? Have a great day. Have a great weekend, everybody. We will see y'all later. Take care of yourselves, everyone. Have a great one. See ya. Bye. Bye, everybody. Bye, Chioma.